mass 10 kg which has been released from here, that is with the initial velocity is equal to 0, onto this inclined plane, and coefficient of friction between this and this is 0.1. We are asked to find the velocity of the block when it reaches the bottom. The length of this slope is 5 meter. So over here, obviously when it is coming down, it means now the frictional force will be at its maximum value. So when one surface is moving with respect to the other surface, then it cannot be a case of self-adjustment. When there is a relative motion between the two surfaces in contact, then the frictional force cannot be self-adjusting. Then it will reach its maximum value, limiting value of frictional force will be used. Over here, the force which is acting over here is mg sine theta, and this way the limiting value of friction force, that is mu mg cos theta, that is mu into n, mu normal reaction, you know, that is how to break the weight into its components, mg sine theta and mg cos theta, mu into n, that is mu mg cos theta. Now this will be acting because we say that this block will be moving in this direction. Otherwise you can also find out that is mg sine theta will come out to be greater than mu mg cos theta. Limiting value of friction force, if we wish to see that is whether this moves this way or not, let's calculate it. Mu mg cos theta, mu is 0.1, m is 10, taking g as 10 meter per second square for ease of calculation, cos 30 is root 3 by 2. So this comes out to be 5 root 3 Newton. Whereas mg sine theta, that is the value of mg sine theta, it comes out to be m is 10, g is 10, sine 30 is half, that comes out to be 50 Newton. So over here we observe that is limiting value of friction force mu mg cos theta, that comes out to be 8.66 Newton, and this mg sine theta 10 into sine 30 is half, that comes out to be 50 Newton. This is 50 Newton, this way is 8.66 Newton. It means the limiting value of friction force will be used and it is not going to be a case of self-adjustment. So when this goes over here, now we have to apply our Newton's second law of motion, F is equal to ma. F is this way, one force is this way, the friction force is in this direction. So equation comes out to be mg sine theta minus mu mg cos theta, this is the resultant force, is equal to mass into acceleration. Over here m and m, it can be taken out and it can be cancelled. It means the acceleration, the value of acceleration is g sine theta minus mu g cos theta. So what we observe over here, that is acceleration is independent of the mass of the block. Whether you put a mass of 1 kg or 10 kg or 100 kg, it is acceleration is independent of its mass. So whether there is a block of 10 kg, it will have the same velocity as a block of 100 kg or 1 kg. It will have the absolute same velocity. Once we have found the acceleration, rest is simple. We can use the equation of kinematics and we can use v square minus u square is equal to 2s, where v stands for the final velocity, u stands for the initial velocity of the block. When our observation, we have started our observation, a is the acceleration, s is the distance which is travelled. So over here v square, v over here is v square minus u square, it has started from rest, 2a is what? You can put the value of theta g, you can take it as 10 meter per second square, mu g cos theta, 2a s is 5 meter. From here you can get the value of velocity, you can find the value of v.